Hi everyone, it's Mr. Green here. I'm going to be taking you through this lesson on gas pressure. But before we get started on the lesson, there's some retrieval practice. If you could pause the video while you attempt these 5 questions and unpause it when you want the answers. Okay, so if you could pause the video now. Okay, let's go through these answers. So question 1, the 3 most common states of matter, the ones we come across most commonly, especially in physics, would be the solid, liquid and gas. Question 2, which state has the most internal energy? Internal energy, as you know, is about the relation of the particles, the space between each other and their relative position, and the energy they've got through movement. So the one that's got movement and the most space between them will have the most internal energy. That would be a gas. Question 3, the least internal energy? Well, that would be the opposite, the one where there's less space between them, where they're not moving around, and that would be a solid. What's sublimation? Sublimation refers to a change of state, and a very uncommon change of state. It refers to the change of state when a material goes from a solid straight to a gas. And finally, what happens to the temperature of a material when changing state, and why? When a material is changing state, when it's melting or when it's boiling, or the opposite way around, when it's condensing or when it's freezing, the temperature always stays constant. This is because the energy absorbed goes to breaking bonds in the material rather than raising the temperature. So today we're going to try and understand how particles in fluids react to different scenarios. Please pause the video and write that LO down as your title. Okay, first thing, our learning outcomes are to explain how observation of Brownian motion gives us evidence for kinetic theory, and use our knowledge of the relationship between pressure and temperature to explain different scenarios. Okay, our first thing, I'm going to show you a brief video of a collapsing can. I'll take you through what's happening with it, and then afterwards pause the video and try and explain what happens. Okay, so in this video we have a small can of drink where they've got a tiny amount of liquid in the bottom of it and they're heating that. That liquid is going to be turned into a gas and forced out from there. Once we've got that liquid turning into a gas and forced out, we're going to place it into some cold water and see what happens. So it's being heated there, there's some fluid coming out of the top of it, some gas. As they place it in, it crushes straight away. It says there the atmosphere crushed this can, but what's happened inside the can to cause that to happen? Pause the video while you work out what's happened. Okay, so when we're going to be talking about here the collapsing can, we're going to refer to air outside the can. That refers to atmospheric pressure. This is the particles of air that are bouncing off you all the time. They're almost a constant pressure on you that are bouncing off you and keeping up that pressure. What's happened inside the can though is the small amount of water in the can has been heated and that turns into water vapour. That then comes out of the can and it forces all the air that's inside the can out of there. Once we've heated it for a while, the only thing left inside the can is really hot water vapour. Once we place it upside down into the ice bath, it cools it down really quickly. So all the hot water vapour in the can condenses and forms liquid. Particles that were bouncing off the side of the can now have been forced together to form that. So inside the can is a really, really low pressure. Gas particles aren't hitting the outside anymore. The particles on the outside of the can are still hitting it and there's nothing pushing them back. So the high air pressure outside the can pushes the can and crushes it right down. We're going to be referring to particles in a fluid rather than particles in a solid, liquid or gas. And a fluid refers to anywhere where the particles are able to move or able to flow around. So a fluid would be a liquid or a gas. We know particles in the liquid and gas do not stay still, they move around. Again, the particles in the gas have got no bonds between them at all and can move anywhere. Particles in the liquid have got very small forces of attraction between them that keep the particles together, but they can move around anywhere within there. Now, our kinetic theory states that matter is comprised of a large number of small particles that are always in constant motion. In a solid, that motion would be vibration. In a liquid, they can move anywhere, but they stay close together. And in a gas, they can move anywhere around at all. As we go from solid liquid to a gas, the average kinetic energy of the particles increases, and the average spacing between the particles increases too. So how do we know that molecules in a fluid are in constant random motion? Pause the video while you talk about that. Okay, we know they're in constant random motion the same way we know about other scientific concepts. We propose theories and then we collect evidence to see if that theory is supported. So in order to get that evidence, we would do experiments, we'd do investigations and record that. So what sort of experiment could we do to try and make an observation to support the idea of molecules being in a constant random motion? Pause the video while you think about that, make some notes. Okay, so we need to observe these molecules and particles to see if they move, and that's easier said than done. Okay, the first person who did this was Robert Brown in 1827, and he observed this constant random motion of molecules. You can see from the video on there, we've got some pollen grains there suspended in water. Now those pollen grains are constantly moving around and not staying completely still. So what's causing this? Well, technology was limited in 1827, so how did Robert Brown do it? Well, what he did was he used a microscope to look at pollen grains moving randomly in water, but he couldn't explain what was happening. It wasn't until Albert Einstein in 1905 who explained the pollen grains were being moved by these individual water molecules, constantly bouncing off those and moving them in different directions. That proved there were particles in a liquid that are constantly bouncing off these pollen grains, moving around, supporting our particle theory. So molecules in a fluid like a gas move in what we call a random motion. And the random motion of molecules can be observed looking at smoke underneath a microscope, or as we've just seen, pollen grains in water. So why do we look at smoke under a microscope and not just air? Pause the video while you discuss that. In order to see something, it must interact with light and reflect it. And light travels straight through air with no interaction, so we have to use something that will bounce light off it. Smoke's perfect for that. It contains tiny little particles that will reflect the light so we can see what's happening. Now in the smoke cell, the air molecules in the smoke cell collide with the smoke molecules and push them, and that causes them to constantly move and change direction. They're constantly hitting air molecules, constantly bouncing off them, which means they move in an unpredictable, random way. So explain why the pollen grains could move when in the water. Pause the video to give an explanation explaining why the pollen grains moved in water. Use the words particle, kinetic and collide in your answer. What happens if we give a gas more energy? So if we give a gas more energy, the particles present in the gas gain more kinetic energy and they move faster. Those molecules would then collide with surfaces more frequently and with more force. This means the pressure exerted by the gas increases. What do we mean by pressure, and can we give a definition? Pause the video while you write your definition of pressure down. Okay, pressure refers to a continuous force exerted onto a surface, so a constant push onto a surface. Pressure can be thought of as force per unit area. So if we spread that force out, it's going to be a really low pressure. If we focus that force on a small area, it's going to be a high pressure. The equation for pressure is just given below. Pressure is force divided by area. Force is measured in newtons, area in meters squared. So the units for pressure would be newtons per meter squared, or we could refer to that as pascals. So pressure refers to when a continuous force is exerted onto a surface. So we can call it force per unit area. We can see these gas particles here, and they're constantly exerting that pressure on there. They're bouncing off that surface. As soon as they hit that wall, they're hitting them with a pressure. Now the pressure exerted by a gas will increase if it's hitting the sides more often or if it's hitting it with more force. So increasing the temperature of any sealed gas container increases the pressure. Here's the two reasons why. The average kinetic energy increases, so it moves a lot more, and the average speed increases, causing them to hit the sides of the container more frequently and with more force. For a fixed mass of gas that has its volume or pressure changed, the number of molecules remains the same. Provided the temperature remains constant, so will the average speed. So why does the pressure increase if we reduce the volume? Pause the video and try and answer that question. Okay, due to having a much smaller volume, the molecules would collide more frequently with the internal surface, and that increases the total force. So even though there's the same number of particles, because they're in a smaller area, they'll hit the sides a lot more often. As the pressure increases, the volume decreases, and as the volume increases, the pressure decreases. Okay, 5 questions here for you to do as a progress check. If you could pause the video while you attempt all 5 questions and then unpause it when you're ready for the answers. Okay, answers coming up now then. So, question 1, what's the kinetic theory of matter? It's the theory that all matter consists of moving particles. Again, if you haven't got that quite right on there, use a green pen to correct your answer and make sure you've got those right. Question 2, what evidence is there to support the kinetic theory of matter? Pollen grains suspended in water move around, and this is due to water particles moving and colliding with those pollen grains. Question 3. As a gas is heated within a sealed container, explain what happens to the frequency of the collisions of particles with the internal surface and the force of the collisions of the particles with the internal surface. First part, the frequency of collisions would increase because the particles are moving faster, so they'll collide with the sides of the container more often. This is because they've been given more kinetic energy. More kinetic energy means they move quicker. Question B, what happens to the force of the collisions? The force of the collisions increases. Again, these particles have more kinetic energy, so they'll collide with a lot more force. Question 4, what would happen to the movement of smoke particles in a smoke cell if it was heated? Explain your answer. Well, particles would move a lot more quicker in a random motion. The particles have more energy, so they move more, colliding with those smoke particles more often. And 5, explain how you decrease the temperature of a gas in a sealed container, and explain your answer in relation to movement and spacing of molecules. We could decrease the temperature by increasing the volume. This makes the particles spread out more. This decreases pressure, and so therefore it decreases temperature. Quick challenge question, and pause the video while you attempt this. What would happen to a balloon if you placed it in a freezer or an ice bath, other than it getting cold? And explain your answer. So pause the video while you attempt that. Okay, here comes the answer for it. A balloon contains air molecules which have kinetic energy, causing them to move around and collide with the balloon's internal surface. Now, the amount of kinetic energy those air molecules have can be changed by changing the temperature. When we place the balloon in a cold environment, this cools the balloon down, and so the air inside cools as well. That reduces the kinetic energy of the air molecules, so the frequency and the force of collisions on the sides of the balloon is lower, reducing the pressure of the balloon. Now, when the pressure of the balloon goes down, the volume of the balloon would also go down, so it would make the balloon a lot smaller. Okay, I provided a load of exam questions for you to attempt. This is based on the work we've done today and previous lessons. Please attempt those questions fully, and hope to see you soon. Goodbye.